Could you get out set tres from last night? Estudiantes de español. Tres means? Three, yes. Even if you don't take Spanish, you should know tres means three. Okay. Uno, dos, tres. Continue, please. Oh. All right, here we go. Good job. That's usually at the point where you use Spanish. All right, so here we go. This is set 3 you're grading, yes? Is your name on it? Yes. Make sure your number is on it, and I'm talking first and last name. Liam. Yeah, you. Okay? Just kidding. A lot of people are doing that. I didn't even say that. No big deal. Just put your last name on it, please. Number 1, did you put 6 spaces down and then put in these digits? 225, 223. Okay, if you did that, circle it in ink as right. You should have your ink out, not your pencil. If you have a pencil in your hand and are changing answers, that is cheating. Is that understood? Okay, you're just grading at this point. It's too late to do them. Number 2, do you have 5 spaces and a 70777, also known as 70,777? Bene, bene. Okay, number 3, you should have 7 spaces and 4. 144,444 with commas, signifying 4,144,444. Number 4, did you get 14,705 and 5,052? 5, did you get something like this? I want to make sure I don't say this properly, or I say this properly, excuse me. Did you get 500,465,182 with digits? What was the goal? Did they give you words to start with? I want to just review what those questions were. 5, oh, yeah, that was use digits to write. Okay, so did you use those digits correctly? 6, did you expanded notation? Give me a digit times a place value. 6 times 10,000 plus 4 times 1,000 plus 3 times 10. Tell me, somebody who wrote 60 times 1,000, are they doing the problem correctly? No. That's not, 60 is not a single digit number times a place value. So it should be a single digit number times a place value. All right, it doesn't, there's not more than one answer. It's this answer exactly, okay? Number 7 is 7 times 10,000 plus 9 times the place value of 1,000 plus 3 times the units place value or the ones. And you're good. Are we cool? Why shouldn't you have missed number 7? It was odd. If you missed it, you should have known it, right? Number 8 is 1 times 100,000 plus 2 times 10,000. Sorry, that was cut off a little bit. Plus 3 times 1,000 plus 4 times 100 plus 1 times 10 plus 9 times 1. After that, I imagine you probably shook your hand out because that's a lot. Number 9. Number 9 was adding or subtracting. In this case, subtracting 377. Number 10, adding and subtracting 569. Number 11, 1,410. Number 12, 1,311. Number 13, make sure you, first of all, included units. Do you have the dollar sign? Do you have the decimal point in the right place and the right numbers? Do you have $10.51? Bene, bene. Number 14, do you have 65 for an answer? Yes, you do. Okay. It's probably a little late, but if you miss one, what do you do again? X to the whole box. And then you learn from your mistake. Okay. These next ones you are solving for a variable. The first day I will cut you a little slack grading, but I will only give you a warning today. X equals 521. If you didn't put X equals, write it in now. And today I will mark it wrong, but tomorrow, if you forget the variable, we will start to X it out. Okay? So if you didn't have X equals, write it in. 16 should have been m equals 364. Again, if you didn't have m equals, write it in now in ink, but don't X it yet. Yes? Oh, yes, absolutely. Yes, you can change the order. 364 equals m is also true. That's fine. And you do that in algebra too. Number 17, a equals 476. Write in the a. Today, don't mark it wrong. But don't forget tonight's homework, you should keep the variable. 18, f equals 186. 19, you're into some kind of different problem. You're going to standard notation from expanded, 85,325. 20 is 6,606. 21, that's a, I think that's a 0. Is that a 0 or 6? 0. That's badly written. Okay, so you should have something like 320,000. What is that? Is that a 9? Yeah, 320,907. Go back to kindergarten, Mr. Rickman. All right, number 22, 5 billion, comma, 803 million, comma, 125 hyphenated thousand, comma, 702. Remember we talked about it the other day, but and is not to be used. And is for a decimal. You should not have and. Understood?
Yes.
All right. Number 23. You're adding all those numbers. I assume you lined them up vertically. And did you get 2,083?
Yes, I did.
All righty. Number 24. Did you get $12.23 with a dollar sign?
Yes.
All righty. I know it's harsh to miss the whole problem if you forgot the dollar sign, but you missed it if you forgot the dollar sign. So do the right thing. Exit out if you forgot. And don't forget it next time. 25, 255,945. 26 is 4,614. Number 27 and 28 are rounding numbers, so you should have written the original number. Did you do that?
Yes.
You should have rounded the number you're rounding to, or circled the number you're rounding to, so you have one circled. Okay? You should have an arrow to the one just to the right of it to say, hey, I'm looking at this one, Mr. Rickman. And would 6 cause 1 to round up to 20 or down to 10? Up to 20. 720 million is your answer. 16,000. 16 is closer to 20 than it is to 10. All right. This guy here. You should have had the number written. You should have 8 circled and an arrow pointing to the one next to it, which is 7. 7. So 87,000. I'm just looking at those stars of the show. 87,000. Is 87,000 closer to 90,000 or 80,000? 90,000. So all the other stuff kind of stays up front and dumps in the back. So I'm going to say that's closer to 716,490,000. I round it up. 29, the numbers were a small enough scale that you could have gone by ones. I went by twos, but if you went by ones, that's fine too. In terms of the numbers they asked you to show, you should have -4 shown, -2 shown. I went by twos, so when I showed 1, I had to actually write, hey, this is what that number is above, and then 6. Do you understand why it's necessary to write that 1 above there?
Yes.
Why? Yeah.
Because if you don't write numbers, it could be like decimal, like 0.5.
Beautifully said. Well done. With just the dot there, who's to say what that is? Is that 0.9 or 0.95? Nobody knows what that is. That's why you write it there. Say, hey, that's 1, by the way. That's why it's necessary. Number 30, I think it was going least to greatest arranging. Is that true?
Yes.
All right. So least is -213, then 123, then 132, then 231, and then 321. How do you say 321 in Spanish? Students of Spanish. 321. All right. Would you please total up how many you missed and put that number in the box next to your name? And if you got a -0, give me a woo woo. Wow, that's a lot of woo woos. Okay. Pass them to a corner of your foursome so I can pick them up quicker, and get out your note, please. Thanks, Sam. Anybody call you just right? Really? Pimples, freckles? Nobody calls you freckles?
Is that what pig is from?
Come on, get up. No, right here. Get this thing done. Awkward. Rico. All right, thank you, my young friend. Never. Unfortunate names to see. I'm glad you did that one. That's a great idea. Thank you. I got you guys, yes? Thank you. Okie dokie, artichokes. Let's see what we got on tap today. What good stuff are we learning here? Oh, boom. All right, now we have to go over multiplication division, but yeah. Oh, thanks. Good job. But I first have to make sure you understand vocabulary. I gotta tell you, I am not gonna focus heavily on all the. Oh no, I guess that's subtraction vocabulary. If you actually use all this vocabulary, so would you please get in a little multiplication vocabulary, right? That which you multiply in a multiplication problem is called a factor. The answer to a problem in multiplication is called a product. So in 3 times 5 equals 15, tell me what are 3 and 5? Factors. And what is 15? The product. Give me a multiplication problem with factors of 3 and 7. 3 times 7 equals a product of
21.
21. That was pretty good. All right. Also, division. Now, I would bet that you know 2 of the division vocabulary words down cold. That which you divide by is called the divisor. And the answer to a division problem is called the quotient. But did you know that that which you divide is the dividend? Okay? Most people don't actually, you don't see a lot that word used a lot. But quotient, boy, I just taught that word in calculus. We did difference quotients in calculus to find a derivative. And if they didn't know what quotient meant, they would have been confused from the very beginning. Quotient is the answer to a division problem. All right. As you probably know, division problems have lots of notations. You could write division. I only have 2 of the ways. You could, besides writing the old box or a fraction, you could actually even write the old division symbol. Let's do this one also. Which of the 3 words goes where? In the first space, you put the dividend, okay? That which is being divided up into pieces. Then you divide it by the divisor. That's the one that does the dividing. And the end result is the quotient. Okay, make sure, would you actually please get that down also, because that notation is used a lot in our book. I will say that once you get to algebra, it's almost all the fractions. Yes, please do, that would be great. All right, so if I gave you a question involving knowing this vocabulary, you would be good?
Yes.
Okay. Right on. Let's move on then to a problem or two, shall we? You will be able to deal with the decimal in a multiplication problem. Don't worry about getting the goal. Let's just go to the problem. When I multiply, now again, I know that you've been doing this for years, but we're still having a few mistakes because on this guy last week, multiplication was the most missed kind of problem. The average on this 10-point thing was more like a 7, 8. And so there we are a little rusty. Let's go over it just to make sure everything goes well, right? So, would you start by organizing this thus? Do I need to line up the decimal point when I multiply? No, you do not. Okay, when you add or subtract, it's about the decimal. On the multiplication problem, you align to the right. You make everything right justified. All right, so let's start the old process. What's the first thing I do? Multiply after writing the number. Sorry. Then what do I do? I multiply through by? We multiply by 7 first. 3. Okay. Now, I multiplied by 7 first. I'm saying if I had 532 7 times, I would get something like 37. Now, the decimal point I'll come to later, but that's the result of multiplying that number by 7, right? Am I done?
No.
Okay, now a lot of people last week just said, all right, I'm done, and circled that. Unfortunately, you just really multiplied, you just did the problem 532 times 7. That's not the question. It was by 27. So now we need to multiply it by 20. I love that you said 20, not 2. We're multiplying it by 2, yes, but we're really multiplying by 20, yeah? And that's why you shift it over at decimal place, because we're multiplying by 20. It's going to be a little bigger than 2. That's why we don't just line it right up. It's one place value greater. So now if I multiply by 20, I would get a 0, then 4, 6, and 10. Now I add the product of multiplying by 7 and by 20, and I get the total of those two multiplication problems is, okay, then we actually make sure our decimal point goes in. Obviously, 27 5 times is going to be more like hundreds, not 10,000. So we need to put the decimal in there. How do I decide where the decimal goes, Ricky? You had it right, so how did you know?
How many spaces you're finding, or how many spaces after the decimal?
Okay, so you in the original problem, you count how many digits after the decimal. Do you agree that in the original problem, there were 2 digits behind the decimal?
Yes.
That is exactly how many times you will move the decimal in your answer. From the far right side, you will then move the decimal point 2 times to the right. And then don't forget units, you're talking money here. Okay? You could think of this as the 27 students each gave Mr. Rickman $5.32. How much did Mr. Rickman get total? And he got, well, 20 bucks 5 times would be 100, so more than 100 makes sense. You with me?
Yes.
Okay. Have my $5.32 tomorrow, please. Thank you. All right, division. I'm just kidding. You don't really owe me $5.32. What? No. $13.70 divided by 5. Now, we're going to actually do this over several lessons because it's so important. These ones will come out clean when you talk money, and the ones that won't come out clean will use remainders. So would you write yourself a note there? If not clean, and by clean I mean goes in evenly, use remainder notation, which we will talk about. In money, you would actually preferably round to the nearest cent, but that'll be a problem later. That won't happen in money problems yet. All right, so this guy, we don't typically divide it in the fraction form. We go to the box form. So in the old box form, what goes in the box? $13.70. You first write the dividend in the box. Okay. What goes outside the box? The divisor outside. Beautiful. Okay. What about the decimal? Okay, decimal straight up. Decimal point straight up. As far as where the decimal will go in our answer, it'll be directly above the one in the problem. All right. Then you start dividing. You go from left to right. 5 goes into 1, no. 5 goes into 13,
Yes.
2 times. Then what do I do? Before that. 5 times 2 is 10. You record it there, and then you subtract. Then what do? Carry down the 7, the next digit, and then you start the process again. You say, how many times is 5 going to 37? 7. Obviously, if you know your multiplication facts backward and forward, you're going to have an easier time with this. You multiply. 5 times 7 is 35. Subtract, and then you bring down the next number. Please keep it nice, vertically organized. Errors happen when you're careless and sloppy. How many times is 5 going to 20? 4 times, and it goes in evenly, yes? So my final answer with units is $2.74. Does it make sense that if you divide 13 into groups of 5, that you get about $2, $3 groups? Yeah. Yes?
With money, don't you like add a penny?
Why would you do that? No, I do not. To answer your question. Why? Maybe when we're talking around. If you're talking about rounding, then we'll talk about rounding to the nearest cent. That might be what you're referring to. But for now, no. Leave it. That's exact. Number 3. Number 3, 735 divided by 12. What goes outside the box? And what goes inside the box? Sorry. 12 outside and 735 inside. No decimal point here. I guess if it doesn't go in evenly, we'll use remainder. So let's just start dividing. Does 12 go into 7? No. Does it go into 73? All right. So if you know your 12s by heart, then great. If not, then go off to the side and give it a try. 12 times what do you want to try? 12 times 72 would be so big. Do you mean 12 times 6? Yeah, 12 times 6 is 72. Do you want it to be a little more than 73 or a little less than 73? A little less. Okay, so that is pretty darn close, so I'd say that was a great guess. 12 times 6 is 72. If you subtract 72, you get 1. What if you had tried 5? Yes? Yeah, it would have been too low. When you subtract, you'd get something bigger than 12. That means you could have had another 12 in there. Go back and fix it. All right, so you want it just enough so that this difference is less than 12. 12 times 12 goes into, bring down the next number. 12 goes into 15. How many times? Once. When you multiply, that's 12, and subtract, that is 3. Now, they say use remainder notation. So what does my answer look like with remainder notation? It went in 60 times with a remainder of 3. And you could write that shorthand instead of writing out the word remainder. You could just write R3. That implies 61 left. It goes in 61 times with 3 left over. Okay. You follow? Yes. It does not. It's not in my mind. That's a good question. I guess I should look that up. All right. Last type of problem. Would you title this part, missing number with multiplication and division? It's like we did yesterday, missing number in addition to subtraction, except this time it's multiplication and division. Yesterday we talked about choose 2 and then what makes sense. Choose which 2 possibilities could happen and which would make sense. If your first example is 12 times some number is 192. Really, the only possible choices that you could do, if it's multiplication, the question is, should we multiply or divide? Do you agree? We wouldn't add or subtract to try and solve this. That wouldn't make any sense. So if it's a multiplication problem, you have to choose, should I multiply or divide? Should I multiply or divide those 2 numbers together? Divide, okay. If I multiplied, I'd get some huge number, and 12 times some huge number wouldn't be a smaller number. That's silly. So divide makes sense. 12 goes into, let's take 12 into 192. How many times does 12 go into 19? once and subtract, and I get 72. How many times does 12 go into 72? 6 times. Evenly?
Yes.
Yes. And so my answer is, I didn't even get you. You remember to give the variable. N equals 16. Okay. On these types of problems, you will not expect a remainder. You won't get a remainder, so don't sweat. All right. Example 5. Some number x over 3 equals 27. People who go way too fast will right away shout, nah. Yes or no?
No.
Why not? Does 9 in there make sense? Is 9 over 3 27? No, that doesn't make any sense at all, okay? So surely dividing didn't make sense, so what should we do? Multiply 27 times 3 gives you 81. Before I circle it and call it good, does that make sense? If you took 81 and divided it into 3 pieces, would each piece be 27? Yeah, that makes sense. So our answer is x equals 81. All right, always check the answer makes sense. Try these here practice problems. Now, would you, when you do these, remember practice problems, you don't have to write the original problem. You can just go straight to doing the solution. So, do A, and let's go the multiplications first, and then we'll check your answers. Again, this is to fill in those holes to see if after last week you're not rusty anymore and you're getting it, or you're still not getting it. So would you do those two? No quizzes, by the way. I will check the practice problems. So if I say set for practice A, you would want to be able to find that in your work. Yes. Either way is fine. You, what are you doing? Okay. So, first one is an example of a problem I might take a few different ways. Your teacher might have taught you one way, and another teacher might have taught a different way in terms of dealing with zeros and the decimal. On some problems, I'm very picky, do it my way, but that's not one of them. If you have a way that's getting you the correct answer, that's mathematically sound, I'm fine with it. When you're done with those two, we'll go over them and make sure you're on the right track on multiplication. Pause and check. Are you done with those two or not quite? Okay. Let me catch up to you. Done with A and B? Okay. I can imagine seeing 3 different types of work, maybe even more. One person might just say, all right, I always put the grossest number on top and the simpler number on bottom, and then I start multiplying. If your work looked like this, then you might have a couple rows of zeros before you started seeing results, and that is perfectly fine, as long as you make sure you use the decimal point at the end, okay? If you did it that way, your work might look like that. Your work might look like that, arriving at $375. If you do it this way, it might be 0015, 006, 003. That person is also going to get $375. Boom. It's also possible you say, well, I'm gonna take that multiplying by 100 in there, give it to $1.25 and move the decimal. So that's 125 times just a normal 3. If you did that, then you might have a much simpler multiplication problem, but either way, it's $375 in one of those ways. You with me? All right. Obviously, you don't have to do it 3 ways. It's just one of those ways. For this guy, if you multiply, what did you put on top? And does it matter? It doesn't matter. Either way, it's fine. If you do that, what do you get for an answer? Actually, how many rows under that should you get in your work? You should get 3 because you're multiplying by 3, 60, and 500. And so when you do that, you should get something like 2,334 for multiplying by 3, yes? Shift it over by 1 place. If you want to put the placeholder, great. When you multiply by 6, what did you get? 4,568? 668? Okay, thank you. And then 500, you'd say, all right, multiplying by 100 would give me 2 zeros, and then times 5. What did you get after multiplying by 5? 2,800. Like that. Okie dokie. When you add then 4, 10, that's a 0. I can't read my own writing. 0, 1, 3, 9, 8, 1, 5, 3, 1, 4. How many times do we move the decimal? None. So your final answer, did you get 438,014?
Yes.
Okay. Would you try C, please? Try C. It's a division problem. 261 divided by 30. If you get a remainder, use R for your remainder. We need some room here. Zeros. How many times are you going with? I like 8. After that, aren't you then done? And so, what is the answer with remainder? 8 remainder, 21. Okay? The minute you don't have anything more to bring down, you're done. That's your remainder. So it goes in 8 times with 21 left over. Right?
Or 8.7, right?
8 what?
0.7?
If I didn't say use remainder notation, I'd say yes. But I did, so no. Okay? We will go into decimal, so hold off on that. But right now, remainder notation. On a multiple choice, that'll be your choice is remainder. So make sure you understand that. Try D. D. 12 into $49.08. Because it's money, your answer will be money. I'm dividing $49.08 among 12 people. And I want to know how much each person's going to get. Try and make it nice and neat. So what did you get for an answer? $4.09. The decimal point should go directly above the one in the problem, so it should be 4.09 with the dollars. All right. Now the last idea we talked about, missing number in an addition or multiplication division problem. Again, you do not have to write the original problem. You can just go straight to your solution. 15 times some missing number is 180. What was that number that made that happen? You gonna multiply or divide? Right, multiplying gives you a huge number. That would make sense in the problem, so it must be dividing. And so your answer is? C equals 12. That makes sense. 15 times 10 would be 150, so a little more than that would be 180. It's logical. Try F. Are you going to multiply or divide? Multiply. You want a big number so that when you divide it by 3, you're still left with 56. So to get a big number, you're going to multiply. And your answer is x equals? 168. That would make sense. If you divided 116 in 3 parts, each part would be 56. Last one. G is the ugliest. See if you're on your game. 368 over B equals 92. What is B? If that works for you. Ready? Done? 4? I'll be that. B equals 4? You sure? You sure? Please, what do you think we should? 4? Does 4 make sense? If you divide 368 into 4 parts, it would be 92 each part? Yes. Yeah, that makes sense. I'm trying to make you sweat, but yeah, that's fine. Okay, so B equals 4. You obviously have this down cold. Well done. All right? So as you do tonight's homework, especially the multiplication division, make sure you are getting these right. If you're not, if everyone else is getting these and you're not, then don't just, oh, well, it must be. Just ask, okay, to fix the problem. Throwing up your hands and saying, I don't get it, doesn't solve the problem. All right? Please ask me if you have any questions. I'll be happy to help. You are on page, what does it say on that paper?